Conrad again. I just wanted to share with you a few more things about the periodic table. Notice I'm not wearing a hoodie today. But anyways, we're back to the periodic table. And I'll show you a few more things that we need to learn. But first of all, we gotta talk about elements again. Yeah, we gotta remember elements each have their own atom with a specific number of protons, neutrons, electrons. Also, elements can't be broken down chemically. They're one element. They can't be broken down more further than that. There's also a few more things we need to know about the periodic table. About those rows and columns again, that I didn't explain last time. But I'm just adding to what we already learned this time. First of all, the rows there's 7 rows. In each of those rows, has a different energy level. For example, row 1 has 1 energy level, row 2 has 2 energy levels, row 3 has 3 energy levels, and so on, all the way through row 7. What that means is that they just have an electron cloud with that many shells around it. For example, hydrogen in row 1 only has 1 electron in its outer shell, and it only has 1 electron, so it has only 1 shell. And as for those columns, they're a little bit different. There's 18 columns in the periodic table. You already know that as you go from left to right in those columns, the atomic mass number gets bigger. But each one of those columns, it also represents the number of electrons in the outer shell. One, they have 1 electron in the outer shell, 2 electrons in column 2, and as you go all the way up to 18, that means it only has 18 electrons in the outer shell, unless you're into the smaller elements at the top of the row column. And also, these are grouped. You know how I talked about how they have similar properties. Those properties are like how they react. When they react with other elements, they behave chemically in similar ways in each column. I mentioned that last time we talked. Along with the rows and columns, there's also different groups of different types of elements that have similar properties on the periodic table. So for example, we have metals, nonmetals, metalloids. So what metals are is metal, basically. And then we have nonmetals, which are usually our gases, and metalloids, which are kind of metals, but not really. And they are arranged in the periodic table as shown on my screen here. And all the red ones are the metals, blue ones are the nonmetals, and the yellow ones the metalloids. Metals are elements that are shiny, good thermal and electric conductors. Means you don't want to touch them when they're hot or touch them when you're around electricity. That would be bad news for you. And they're also malleable, meaning we could like bend them and make stuff in any way we want. Like for example, construction, we use steel to make buildings. Make steel beams, knives, anything made out of metal, wire, anything. That's what malleable means. And the nonmetals are elements that are dull, poor thermal and electric conductors. Brittle and not unmalleable means they break easily. And some of these are a lot of these are also gases, which makes sense because you can't even see those. And as for the metalloids, I got one example here, boron. It looks like a metal, but it's not really a metal. They have both non-metal properties, non-metal and metal properties, which is they're the kind of the weirdos that kind of get mixed between metals and non-metals. We already know how to read a periodic table, but just for review, the atomic number is the number of protons, the letter is the element symbol, the atomic mass is the combination of protons and neutrons and can be used to find the number of neutrons if you subtract it from the atomic number from the atomic mass. And remember, the atomic number is the number of protons, but the number of protons is also equal to the number of electrons within that element or atom. So that is all I have for today. I have no jokes, but I'm just putting it out there. There won't be any jokes today. And you guys all have a good afternoon.